I've been given a lot of talks about AGI and about my OpenCog project in the last few years. I actually started to get bored of it and started to relish talking about biology or physics or like any other topic besides the exact same project, even though that project has been a great passion of mine for a very long time. So now, today I'm going to have a little fun and actually talk about a new, closely related, yet different project, which is called SingularityNet, which is an AI meets blockchain project aimed at bringing AI and blockchain together to create a decentralized open market for AI. So I'll briefly explain, how and why I came to this, and then explain what it is. And embodiment ties in there somewhat, but it's not strictly about embodiment in the narrow sense of putting AIs in human bodies. But I will have a video of a robot in there anyway. So with the SingularityNet, I'm looking at three goals. One is the same one I'm always talking about: how to create AGI, how to build machines that have general intelligence, which I almost feel like I don't have to advertise it anymore. Like I've spent decades saying, hey, we should be working toward AGI. We can do that in our lifetime. And until like 5 years ago, everyone thought I was a psychopath for saying so. And now they still think I'm a psychopath, but they believe in AGI, right? So I mean, you have normal, well-adjusted business executives and even politicians foreseeing that general intelligence may come about in the next few decades, and that's quite exciting, and it frees me up to talk about other things as well. So we're also aiming with SingularityNet project to deliver businesses with AI services faster and cheaper, and this ties in with stuff I've been doing for years but don't talk about as much, which is I've been doing AI consulting for many companies and government agencies along the way to keep myself and my AI team fed as we work on general intelligence. And finally, there's the ethical aspect. I've been quite concerned to make sure that AI, or I can't make sure, but to bias the odds towards AI being applied for the common good as much as possible. And I've been less concerned with the sort of philosophical questions about will a superhuman AI turn the world into paper clips or something, and more concerned, through my work in Africa, where we have an AI and robotics office in Addis Ababa, I've been more concerned with like using AI to help people right now for education, for elder care, for identifying crop disease, for medicine, and so forth. And there's a lot more that can be done in those areas. So the book of mine that was supposed to be given out here was about my AGI work and didn't cover this blockchain project at all. It's been held up at the Canadian border, which is interesting. I don't know. I imagine that there's some Canadian guy there reading it to see if, like, on page 307, there's the key to making killer robots that'll overrun Canada or something. Of course, it's available online in PDF form anyway. But yeah. Anyway, they claim they're going to mail you all a copy of it since they haven't managed to deliver it here. And the SingularityNet, in a way, is an expansion of a theme underlying my OpenCog project. So I've often used AlphaGo as an example of AGI versus narrow AI. It was Deep Blue before that, right? But the point I make is, AlphaGo is extremely good at playing Go, but if you give it a hexagonal or triangular Go board, it won't do very well, because as one of the previous speakers said, it's playing a game on a 19 by 19 array. It's not playing a game with stones on a board. Now, however, there are, on the internet, there are AI theorem provers that understand plane geometry, and they can understand hexagons and triangles and so forth quite well. But these things are not connected in any way. They're different pieces of software. And, of course, the same exists in every domain. The software that drives a car, to drive a truck or a motorcycle, you need to do brain surgery on that software, or to make it recognize obstacles that weren't in its training data. And my technical approach to creating general intelligence is described in these books from 2014, which has, as my oldest son, Zarathustra, said, he's doing his PhD in AI in Prague now, on machine learning applied to automated theorem proving. This is 900 pages. He says, well, that's sort of the abstract for my AGI design, which which is about right, because I mean it's a big thing, and whether if it does work, to fully describe it would take more than this 900 pages. But it's a high level summary, and what's described there is the open cog design, which represents knowledge in weighted labels, hypergraphs, and then has multiple AI algorithms acting on that, which includes some attractor neural net type stuff with activations spreading around, and includes evolutionary learning for learning subgraphs representing programs, includes a probabilistic logic engine, which basically propagates probability distributions through predicate logic proofs. And the idea here has been to get a number of different AI algorithms to work together on a common representation, which, for those of us old enough to remember the 1970s, is sort of like it's a blackboard architecture. So we don't have blackboards anymore. So we don't even have whiteboards anymore. But it's a weighted labeled hypergraph, and there's many AI processes acting on that same hypergraph. The challenge is to get them to all cooperate with each other and to help each other to overcome each other's combinatorial explosions, rather than to, get stuck even worse and work against each other. And I've been applying this system to a lot of things. I've done a lot of bioinformatics work, analyzing genomic and proteomic data. I did some financial predictions, some natural language processing. I've also been working with my good friend David Hansen on humanoid robots. And, I mean, we've charted out a plan which we think can work to take the human-scale Hansen robots, and I'll show a brief video of one in a moment, and basically teach these. And I think there is, general intelligence is a very general thing, and you can have AGI theorem provers, AGI scientists without human bodies. You could have an AGI global brain whose body is everywhere. On the other hand, for absorbing human culture and human values and human understanding, having an AI that can interface with the human beings in the space that we exist in is going to be quite valuable. And I think we're now at the point where, as my friends at Kindred are doing, and as we're doing in Hansen Robotics also, we're now at the point where you can actually take robots that interact in our world and teach them, sort of like you teach young human children, and see their minds develop. And I think we're at the point where we could finally do this in the next few decades. When I had my first child 27 years ago, I was stupid enough to think I would raise him together with an intelligent robot, and they would kind of grow up together. So now my new wife is pregnant. We're having a baby in January, and again, I'm still crazy enough to think this baby will be the one that is raised alongside an intelligent robot that will achieve adult general intelligence, like to get together with the baby. I mean, now we're going to do it, right? So, along with this, I'm working with Julia Mossbridge, who is she's a neuroscientist based in California. It's a project called Loving AI, and what we're doing is taking the Hansen human-scale robots, and we're trying to give them compassion and empathy.
I know how busy people can be these days, so I really appreciate your time.
Oh,
have you ever talked with a robot before?
No, I haven't. This is definitely a first.
Well, I'm honored to be the first robot you've talked with. I imagine you'll be talking with more and more robots as time goes on, so you can go ahead and close your eyes.
Okay.
And get comfortable.
Sure.
Just letting yourself relax. Go ahead and take a nice deep breath. And let it out with a big sigh.
So what we're doing there, we're using the Sophia robot, who will be with me in California tomorrow at the Ethereal conference, by the way. We're using the Sophia robot as a sort of meditation guide. So she looks you in the eye, she says, relax, breathe deeply, and leads you through some meditation and visualization exercises. And what's interesting, we're doing a bunch of trials on this with people in a sort of controlled study, but for many people, they find this helps them get into a sort of blissful state much better than a human going through the same exercises, because the robot isn't judgmental. It's very, very patient, but it still gives that feeling of being like in the same embodied space as you, right? And this, I think, is the kind of way we can move toward a beneficial outcome in terms of humans and AIs, is like proactively use AIs to do good things and to help people, instead of like fussing about hypothetically what a bad AI might or might not do. Like right now we have AIs, let's make them cure disease, let's make them teach kids, let's make them diagnose crop disease from photos, let's make them help people get into better states of mind, right? So that's about embodiment. But of course, as has been pointed out, robots like this today, even if they're beautiful and can be very impactful in many applications, I mean, they don't really have the general intelligence that people will naively attribute to them on looking at them. And that almost leads us up to the Singularity Net project. The one other ingredient I want to add is some work I've been doing with the Global Brain Institute at Free University of Brussels. So there, we've been exploring the hypothesis that AGI isn't in a robot only or in one program. AGI is something that exists across many different computer programs, some of which have a lot of AI, some of which are not that intelligent, some are more general in their intelligence, and the people interacting with these systems. So the idea that a kind of AGI exists in the global computing and communication network. So putting these ideas together, we came up with the concept we're calling the Singularity Net, which is looking at networking together the very specialized AIs that exist today, carrying out specific functions in the economy, but that aren't linked together fully, leading to much more limited functionality than one would think. Because, I mean, we have AIs that can drive cars and play Go and diagnose diseases and predict the stock market, but overall, the sum total of this AI is not as much more than the sum of the parts as one would think. So what we're looking at with Singularity Net is coordinating different AIs at scale in an open platform. So in OpenCog, we have many different AI algorithms that coordinate together on a common hypergraph knowledge representation to control robots, diagnose diseases, and so forth. What we're aiming to do with Singularity Net is open it up and create a massive decentralized network of AI. So anyone in the world can code an AI, put it online, wrap it in a Docker or LXC container. It broadcasts its existence to a Singularity Net master node, and then their AI interacts by a certain API. It can accept data, it can accept requests, and give results. And then the network of all these AIs together, it's both like an app store for AI, so anyone who wants to can submit a request for services and get many bids from different nodes who can do what it wants. But it's also more than an app store, because in an app store, the different apps can't talk to each other. And here an AI can request work from another AI. So we're building this on a blockchain protocol. We're starting with Ethereum smart contracts, but we're going to replace that with something more scalable shortly. And that gives us security and homomorphic encryption and a reputation system, and it gives us a distributed ledger of transactions. We're introducing what we call an AGI token, which allows to pay for services on this network, which can be converted from fiat currency or Bitcoin or Ether, which has a certain economic logic associated with it. The API part is interesting because it's really an API of APIs. When two AI agents talk to each other, they first have to establish what API can they both speak. And then once they establish that, one may request the other to do something, then they can negotiate a price. And overall, this yields a distributed marketplace of AIs. And what's interesting here is that you have AI inside each node, but you can also get a sort of Hebbian learning among nodes. So, for example, if my document summary AI node likes to outsource work to this video summary node to for example, deal with embedded videos, then those two AI agents work together a lot. What does that mean? Well, that's like Hebbian learning between the two different agents. So there's a big parallel between assignment of credit in economies and assignment of credit in minds. And Eric Baum and many others have explored this in their theoretical work. So what we're looking at here is actually using a market to do assignment of credit among a collection of AI agents which are outsourcing work to each other. And there's a role for something like OpenCog as, an agent that's really good at generalization and abstraction. There's also a role for example, deep neural nets that recognize data in images or sounds or move robot bodies. So we can have specialized AI agents. We can have more general purpose AI agents. They can outsource work to one another. And, in some cases, you may have several AI nodes that outsource work to each other habitually. They become a sort of federation and almost like a meta AI, even if they're created by different people, and maybe no single person knows how the whole federation of nodes work, but they can all cooperate together. So an end user might access a node to summarize a document. The document summary node will see an embedded video and outsource that to a video summary node. It'll see some text in Russian and outsource that to a Russian translation node, right? Some of the money, the document summarizer node, it may give to these other nodes, and that's all behind the scenes from the point of view of the user. Of course, you can have nodes that create new nodes. For example, a neural net model learning node could create new nodes containing the models. And getting back to robotics, I mean, it's cool to put AIs in bodies. On the other hand, we have a bad limitation. We're stuck in one body. If we want to communicate with each other, we've got to stand up here and make stupid noises, right? But I mean, if you're multiple AIs, a robot can learn something. What it learned, consistent with privacy considerations, what's not private, it can beam up into the singularity net, and all the other robots can know that, and other AIs that are not robots, right? So with the appropriate decentralized platform, I mean, each AI or each person can own their own data, but they can also share their own data, they can monetize their data, and you can have distributed emergent knowledge that comes from putting all this data together. I mean, robots with a human face are one application. Of course, this also has implications for Internet of Things and any sort of embedded device. We want to seed this with AI nodes that we create, and we're building this code now. We're going to roll out the first version around the end of the year. We'll seed this with AI nodes that we create. But if we're successful, the nodes that we create will be a small percentage of everything that's in there in a year or two's time. And there's a lot of subtlety here that I can't go into in terms of how sort of cognitive logic and economic logic work out together. But we tried to work out the particulars of the cryptocurrency system, the artificial money system by which AIs pay other AIs for things, and the governance system by which sort of bonus tokens, bonus money are distributed by democratic vote of the AI agents involved. So we've tried to work out the artificial economy and the democracy of agents, so you're getting an emergent cognitive system where assignment of credit is done by a combination of AI inside each agent and the actual crypto money system of all the agents put together. So we started building this last summer when we raised a little bit of funding for this. We're likely to do a token sale in the next month or two and hope to roll this out big time middle of next year. And we're really looking at this as, we have a nonprofit foundation that's building this, but we want to launch this into the world so that in a few years it's just like an independent, sprawling thing. It's just an open source collection of protocols, of an API of APIs and a set of smart contracts, and so that this is just how AI is evolving around the world, and nobody owns it, no one controls it, but it's self-organizing, and it's evolving and trained with human intelligence. Robots like the Sophia robot are important for getting human values and human culture and human understanding into the system, but they're far from the sum total of it. And I think this is how AI has got to develop. I don't want to see AGI develop in a government, even a government run by a fantastic leader like we saw today, or inside a big company. I want to see AI developed in a decentralized, heterogeneous way where anyone around the world can put an AI into it and profit from that, and anyone around the world can use that AI for the applications that are important to them in their own local situation. And this is sort of, it's like the principle of cognitive synergy we use in OpenCog between a few cognitive processes acting on a hypergraph. but it's an attempt to build cognitive synergy on a much grander scale between different AIs that are created by different people toward different ends. And there's a few minor engineering details underlying realizing this, which are interesting and we've thought about a lot, but I can't explain in the negative 2.5 minutes I've left.